Hey everyone, today we are officially starting the last chapter of this year before we start our AP review. And I actually think you guys are going to like this chapter. It's going to be pretty straightforward, and a lot of the processes we're going to be using are similar to ones that we've gone through in the past and have become pretty routine to us. So to start the chapter, we're going to be talking about areas in the plane. Okay, and really we're going to be focused on finding the area between two curves. So up until now, we've practiced finding the area between a curve and the x-axis. So that's been routine to us. We know that finding that is just integrating the function over the integral from a to b. So we already knew that this was going to be the integral from a to b of f of x dx. Right? And we know that gives us the area under this curve. What we're going to be learning now that's a bit new is we're going to be finding the area between two curves. So now instead of going between the curve and the x-axis, we're actually taking two curves, in this case f of x and g of x, and I want to know about the area that's trapped in between. So here's how we're going to do it. So first of all, if we have f and g, if they are continuous functions with f of x greater than or equal to g of x throughout the interval from a to b, means f of x is always on top of g of x. So I'm going to make a note. Okay, then the area between the curves between a and b looks like this. We're going to integrate from a to b. And we're going to take f of x minus g of x dx. And so here's how we'll refer to it a lot and what I want you to think about. Really what we're doing is taking the integral of the top minus the bottom. Okay, so it's just the integral of the top curve minus the bottom curve. So now if we kind of look back at these examples we were talking about, right, really we know that the x-axis, its equation is f of x equals 0. So really what we've been doing this whole time is taking the integral from a to b. I know my top is f of x. Well, my bottom in this case is just 0. And that's why we were just able to integrate from a to b, integrate f of x dx. So now, when we look at these problems, we're going to be doing the integral from a to b. Again, we're doing our top minus our bottom, and we're going to integrate with respect to x. So that's all that's new for today, is really using this top minus bottom to find the area trapped between two curves. So let's go ahead and we're going to do 3 examples so we get the idea of how this works, and then you'll have stations to work through some more problems in class. Okay, so for our first problem here, we're going to find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals x. And you'll note here this is a no calculator problem. So the first thing I'm going to do is sketch a graph. These are pretty easy functions to work with, but I want to make sure we all have a really clear picture of what's our top curve and what is our bottom curve. So let's do this. Okay, so now I'm going to do, let's see, y equals 2 minus x squared. I'm going to do that in my purple pen here. So I know that's a parabola that opens down. I know its vertex is there. And let's see, its x-intercepts are going to be between 1 and 2. So it's going to look like this. And again, I'm not worried about it being perfect, but I want to get an idea for what's the top and what's the bottom. So that's my y equals 2 minus x squared. And then we're going to do y equals negative x. So we know this is a line. Its y-intercept is 0. And then it has a slope of negative 1. So it's going to look like this. Okay, so now given my picture, it's pretty easy to see that this one is going to be my bottom. My parabola is my top. And what we're trying to calculate is the area that's trapped between those curves. So this region here. So to get started here, we know we're going to integrate. Now, we said it's going to be top minus bottom. So our top, I know, is 2 minus x squared. And then I'm going to subtract my bottom. Now, I have to be careful here to use parentheses. I'm subtracting a negative x. I'm going to close off my integral with my dx. Now, the other thing I have to decide here is what are my limits of integration? So what I need to find are the two intersection points. And those will give me my limits of integration. So I need to determine this point here and this intersection point here. And those will give me my top and bottom limits. So to do that, all I'm going to do is set these equations equal to each other and solve for x. So I have 2 minus x squared equals negative x. Now to solve, I want everything equal to 0. So I'm going to move to the right. So I'm going to have x squared minus x, or excuse me, x squared minus x, and then I'm going to have a negative 2 is equal to 0. Luckily, this one's going to be easy to factor. So I have x and x. I'm going to have a negative 2 and a positive 1. So now I know my x's are negative 1 and positive 2. And again, those are just going to serve as my lower and upper limits of integration. So now I have a definite integral that I can anti-differentiate and evaluate. So I'm going to clean this up a little. It's a negative 1 to 2. I have 2 minus x squared plus x dx. Sorry about all my fingers in the way there. So my antiderivative is going to be 2x minus x cubed over 3 plus x squared over 2. And I'm integrating from negative 1 to 2. So let's see. I'm going to have 4 minus 8 thirds plus 4 divided by 2, so plus 2. And then I'm subtracting negative 2 plus 1/3 plus 1/2. All right, so a little more simplification. Let's see, I have 6 minus 8 thirds. That's 18 thirds minus 8 thirds is going to be 10 thirds minus, let's see, I have negative 2 plus, let's see, if these are 6 plus, let's see, 2, 6, 5, 6. So that's going to be a negative 7, 6. Sorry, it took me a little bit to work that out. So now what I have is 20 over 6 plus 7 over 6 is 27/6. Or if I divide by 3, 9/2. Now, what I don't want to happen is that we get lost in the details here of evaluating this integral. That should be old, something we really don't have to think about. But again, the idea is just calculating that integral, top curve minus bottom curve, from those 2 points of intersection. Okay, let's go ahead and do another problem. Now this time in number 2 is going to be a calculator problem, so we're going to use that to our advantage here. So I am going to first plug in these functions into my calculator. Again, I need to determine which is going to be my top curve and which is going to be my bottom curve. So in the y1, I'm going to put in my 2 cosine of x. And let's see, y2 is x squared minus 1. And I'm going to graph those. Now I can see here's my cosine function. And then my parabola, my x squared. So clearly my cosine is going to be on top, and the x squared, that parabola, is going to be on the bottom. So I'm just going to sketch this. Again, I like to have that in mind so I can keep things straight. So let's see if I can do this. I'll put this off to the side. and I'm just going to sketch a picture. So I have something that looks like this. Oh, I'm sorry, I meant to do that in purple. So let's do this. Here's our 2 cosine x, and I'm just going to underline that so I keep things straight, and then I'm going to do my x squared minus 1. Okay, so there's my top and my bottom. And now remember, we need to find these points of intersection. And so we're going to use our calculator to help us do that as well. Since this is a calculator problem, I'm going to use that for as much as I can. So I need to find my x values where these intersect. So I'm going to do second calc. And now I want to use intersect. We're not looking for zeros, but we're looking for where these curves intersect. So I'm going to choose 5. Now, you can see here, I'm on my cosine function. So I'm going to go down here, kind of near where those intersect, and I'm going to hit enter. Now it's going to jump me up to the second curve. So you want to make sure you're on the other curve now. And I'm going to hit enter again. It's going to say guess. I hit enter. And it's giving me now that point of intersection. So I'm going to say x is approximately, we have negative 1.265. And then I'm going to go ahead and do my other intersection point. Again, I'm doing second trace to get calc, 5 for intersect. And now I'm going to scroll over here to my other intersection point. So again, I'm on the cosine curve. It's telling me which curve I'm on. If I hit enter, it's going to jump me to the other curve. Hit enter again, it's asking me for a guess. And one last time, and there I get my intersection point, 1.265. So now we're going to integrate. I know my intersection points are negative 1.265 to 1.265. I'm integrating my top function, again, is our cosine, so 2 cosine of x. And I'm subtracting, again, I'm going to use parentheses, my bottom function, which is x squared minus 1. Close that off with my dx. And again, since this is a calculator now, we're just going to use our calculator to find that area. And again, the area we're after is the area that's trapped between those 2 curves. So I'm going to go here, let's see, to Math 9. Negative 1.265. I'm going to enter it just like it is on my paper, to 1.265. I have 2 times the cosine of x minus, again, I'm using parentheses for x squared minus 1. There's my dx, and I get an area that's approximately 4.995. Again, I always go to 3 places because that's the standard on the AP exam, unless it's otherwise stated. Okay, we're going to go through one last example here, and then that'll be good for us for today. All right, last example. This is no calculator here, so we're on our own. And actually, we're just going to focus on the setup here, not so much evaluating the integral, but making sure we get the setup. So I've got the area of the region R in the first quadrant. So I want to make sure I'm focused just on the first quadrant here. So I'm going to highlight that. It's just specifying the region in the first quadrant. So it's bounded above by y equals square root of x, and below by the x-axis and the line y equals x minus 2. Okay, so again, let's take a look at what we've got here. So again, I'm focusing on the first quadrant here. So y equals square root of x. Again, they said that's the top curve. I'm just going to be consistent and use my kind of purple color here. So square root of x, we know looks like this. And then below by the x-axis and the line, y equals x minus 2. So x minus 2, let's see, has a y-intercept of negative 2, slope of 1. So it looks like this. Now, here we have to be careful because it's actually giving us 3 boundaries here. And maybe I'll grab another color. So it told us we're bounded above by root x, below by the x-axis, and the line y equals x minus 2. So actually, I'm closed off. I'm limited to this region that's right here. Now here's what I want to notice, and here's why I stopped. If I start going from top to bottom, I know that my top is that kind of magenta color, and the bottom is my light purple. But what I notice when I get to that point is now my bottom curve changes. Instead of it being the x-axis, now I have the blue line as my bottom. So because that bottom changes, I'm going to need to split my integral up. So I'm going to make a note here. We need to split into 2 integrals because the bottom changes. Okay, so we need to be really careful here. So what we're going to have is the integral. Well, let's see. My first one, I know I'm going to be integrating from 0 to 2. My top over that interval is going to be square root of x. And I'm going to subtract. Well, that was just the x-axis, so really that was 0. And then I'm adding the integral from 2. And let's see, these are going to intersect here at 4. And now I've got my top is still square root of x. But now my bottom is my line x minus 2. So like I said, I'm not going to worry about us actually evaluating this integral. For right now, I just want us to be focused on that setup. Because our bottom function changed here, we needed to set up 2 separate integrals to find that area. So that's really kind of an introduction to area between curves. In the later videos, we'll be looking at some special techniques for resolving some of the issues we see here. But for tomorrow, we'll be practicing with just calculating basic areas between 2 curves.